quadratic. You know it is a quadratic. Okay? And as you can see, it's this little bit of curvy one that's been drawn here. Don't forget, not only do I want to pick polynomial degree 2 or quadratic, but I also want to display the equation and the r squared value. It's going to be important for me to be able to do here. Okay? And so there I have my equation for my quadratic. Okay, and I know it's a quadratic because you can see x squared here, then you can see x, and then you can see a constant. Okay, maybe you can zoom in, or I don't know, pause it and have a look, scrunch your eyes, or even go ahead and do this tutorial along with me so you can make sure that you can do that. Okay, so getting all these is not going to take us very long to do. Again, same process. We go to add chart element, we go to trend line, we go to more trend line options. Okay, and then we just pick another one. I'm going to pick polynomial, and I'm going to pick degree 2. That's called a cubic. You can keep on going up on these, but eventually you're going to get a perfect correlation because the number of points is going to be very close to the degree that you have. I think Excel goes all the way up to degree 6. I'm going to only go up to degree 3. Okay, but you can keep on going if you want to. It's up to you. Display my equation, my r squared value, and then you're going to see this equation is quite a long one. And long, obviously, because it's a cubic. So it's going to have an x cubed, an x squared, an x, and then a constant value. Okay, or y equals ax cubed plus bx squared plus bx plus cx plus d. Okay, of course we've got an r squared value. Now so far it looks like linear is the worst by the r squared value. Quadratic's pretty good, but cubic looks even better at 0.824. So we still don't know which one's best. Okay, but we're piling up in equations. Okay, then what we're going to do again is we have a couple more that I want to do. I want to be able to focus on. So go to our trend line, go to more trend line options. Okay, this one's very common in nature, so it's something that we often use, and that's exponential. Okay, it's got the most complicated equation for those of us who aren't too comfortable with algebra, but it's not as bad as you think. Okay, and they're going to put it in y equals a times b being the base to the power of something x. Okay, and sort of boil it down to that. And they're going to use something called e to the x as the base function. So when you look at this one here, you're going to go all the way down here. It's really little looking, but you have y is equal to 12.77. That's the a value. E, which is your base. In this case, the negative 0.163x. Okay? That's our exponential. And you can see the exponent is in the x. Okay? And then finally, I'm going to go to a power function. Okay, so again, very repetitive. Just changing who it is that I'm working with. Again, this is the normal screen. Okay, a power function. Equation, r squared value, and then there you have it. And there's your power function over here. I guess I'll have to put it over here. I'm running out of room. Okay, and there's my power function. Hopefully what you'll notice is that there's my a value. There is my base. My base is x. And if you look at the exponent is to the negative. It's a constant. Okay, it stays the same. So the variable part is the base, whereas in the exponential, the variable part is in the exponent. Okay? Anyway, so based on this idea, these are all my equations of best fit, and that's how you do that. Now, according to this, my power function is the worst. My linear is second best. My exponential is third best. My quadratic, very close to exponential, is second best, and then my my cubic tends to be the best. Okay, but I'm going to show you another way to make this quantification. That's what this stuff over here is about. Okay, but I'm going to break this up into some pieces so it's not too much for us to handle. So go back, open up your Excel file, try this, play with it, make sure you know how to do it. You can get all these equations, and then we can move together from there.